plus 7 times x. Okay? Now we put back at 7x. I don't want to put the multiplication side. Looking at that, we recognize factorize means what is common to both sides. The separator is here. What is common to both sides? Both of them have an x. Start going, please. You open bracket now. What leave back? An x plus 7. If we go backwards now, this is backwards. X times x plus 7. X times x is x squared. X times 7 is 7x. You see that? So we're doing the reverse process. So this results in, it's supposed to be able to watch this and do that there. You realize it's got 2x in it, it's got an x, you pull up the x. You need x times x to get x squared. You need 7 times x to get 7x. No, this one is the same. You might think it's the same, but it's not the same. This is what you call, nobody remember to put this in the chat. Difference of two squares. To do this, you need to know your square numbers. 1 squared is what? 1. 2 squared is 4. 3 squared is what? 4 squared. 5 squared. 6 squared. 7 squared. I see that over here. 8 squared. 9 squared. Wow. 10 squared. 100. 11 squared. 121. 12 squared. 13 squared. I don't come now. 169. 14 squared. 196. My taking fast by. 15 squared. 16 squared. 17 squared. Back check, 29, right? 289. Yeah. So break quicker than the calculator. 8 squared, 324. 324. 19 squared, 361. 1981. Like good. Let's stop there. Okay? Million or more. Binomials where you have let me see. Must put it x plus x plus y, x minus y, and the friends of those is called perfect squares. And here there's more space. Sorry, I should have put more space. Let's go, guys. X times x. Foil. First, outer, inner, last. X times x is what? X times negative y. Good. You have to put it in alphabetical order. Y times x. Plus xy. And y times negative y. Good. You have an apple? You take away an apple. Or you have a xylophone? You take away a xylophone. A xylophone, take away a xylophone is what? No xylophone. So we simply do that. That's that? The xylophone eliminates itself. So it's like a big zero. We don't want the zero in here. We just simply take this and shift it across. You understand? Good. That's the difference of two squares. Perfect squares as in x plus y squared. When we say x plus y, close bracket, open bracket, x plus y. Start waiting for some people, please. You gotta get that right. You just simply multiply this by itself twice. y times x plus xy, and y times y. These two middle terms that are alike, so x squared equals, how much xylophones have? A xylophone plus a xylophone. 2 xylophones, good. Somebody see that?
Yeah.
Good. That's one perfect square. Come in. That's one perfect square. Another perfect square can have, instead of a plus here, we can have a minus, where we have x minus y, close bracket, open bracket, x minus y. Okay, so what's the difference now? Up here, we have plus y minus y. Have you seen that? Down here we have what? Plus y plus y. And down here we have what? Minus y minus y. This gave us no xylophone in the middle. This gave us what? 2 xylophones in the middle. And this will give us negative 2. Let's go. X times x. X times negative y. Negative xy. Minus y times x is negative xy. And negative and negative is a positive y squared. Good. You owe a xylophone, you owe another xylophone. What happens? You owe 2 xylophones. Did I see that? Good. So now, this is this is what? Positive 2xy, and this is no xy in the middle. 0. Okay? It disappeared. You see that? So whenever you see a plus and a minus there, it goes to this. Now, look at this and look at this. You realize something? 49 is really what? A square number. See that? If you square root 49, you get what? 7 squared. So I can write this now, instead of writing it as x squared minus 49, I can rewrite it as x. Different? No. It's the same thing. Yes, ma'am? Is it good? Oh. I can find the two factors. Whenever you have this, that may decay from something like this. So x was here, y was here, right? Everybody see it? Yeah. Let's do the same thing here. X, one gonna be what? Plus 7, good. The next one gonna be what? Minus 7. Let's do it backwards in our heads now. X times x is x squared. X times negative 7, negative 7x. 7 times x is 7x. And 7 times negative 7, negative 49. That cancels that, leaving with what? X squared minus 49. Everybody see that? I know how to find for some people, but you're not trying to keep up, okay? But see that this was just a little back checking. Just for you to appreciate that when you do this, you get these two. So the three types are plus, minus, plus, plus, minus, minus. Everybody see that? The question I'm supposed to be asking me now, which may nobody asked yet, because I'm still waiting. Can this be minus y and this be plus? Can this be minus y and be plus? Yes. You can actually switch them up. You're going to get the same answer. Okay? So just now, the minus one could be first, the plus one could be last. Ain't the difference? You understand? Minus 49. How do you work it out again? Open bracket, watch. Do this for me. Right? You put square here, put square here. What times what give x squared? X. What times what give 49? Then you simply do this now. X plus 7, x minus 7. You're done. Don't try to think, don't ask what you want. Minus 7, x plus 7. Anybody see something, recognize something here? Yes. You can. That into 7 goes once into this 1. Leave you with? Good. Nothing else to do. Nobody gonna try to cancel this x with this x. Why you can't cancel this x with this x? Guys, I explained that today. Why you can't cancel this x and this x? And there's no multiplication sign anywhere. If this was this, it was times 7, then you could do that. But that's the only way you can cancel. When you have a multiplication either on the top or the bottom. But since it's not that, remember I told you, nobody cancels a minus or plus sign. It's done. There's nothing else to be done for this. Let's bend story end. Times x. I don't want to put the multiplication sign between x. Everybody understand? I'm going to remove this. Okay? Everybody understand? When you have algebra, you don't have the multiplication sign. So we have x squared and then x to the 6. 3, 4, 5, 6. Well, how much x we got here? Good. So we have x to the 8. The shortcut is x squared times x to the 6. The simply do what? We add the powers. You give x to the 8. Alright? So these two come from here, and then these here come from here. You understand? It's just simply combining them. Because really between the x squared is a multiplication sign between the two. And between all of these is multiplication signs, okay? You understand? So you just simply combine them. You guys understand that? B squared times b to the negative 4. That's the answer. B, because this is negative, you stop, you still ain't add. You still got to add. Remember the rule is, when the base are the same, and you multiply, you add the powers. If the powers negative, add them still. What's that? Another way I'm going to show this is b squared and between negative 4 is in fact between negative 4 is in fact b, because it's below. Right? That will be 1 over b squared. That's the same answer. Because they have b and b, between negative, entity to negative power. Remember I teach you that. Remember entity to negative power is what? Fractions, right? I remember talking about that? Negative powers are dealing with decimals and fractions. That's why I have to put them below here. That they are below, they are fractions. So this and this is the same thing. Take down that too. And you know that these two are the same. When you have a negative power, I have another in physics. You have a negative power, you deal with a fraction. What's that? K to the negative 3 is 1 over k cubed. So t to the negative 7 is 1 over t to the positive 7. When it goes below, the power comes positive. There is facts you need to know. The negative 2 still means 1 over q squared. So you have 1 divided by 1 over q squared, which is 1 over 1 times q squared. Here. Let's see, make sure. Yeah, what you need? Again, the q squared over 1 is q squared. But start having q squared here. Yeah, that's it. That's what the q squared. I questioned myself, but I get the answer. You see that? Because this, when it's negative, is 1 over q squared. So 1 divided by 1 over q squared. 1 divided by 1 over q squared. 1, you don't divide fractions. 1 times q squared over 1, you get q squared. Anyway, go over like that. And here is negative outside. Okay? Let's do that. Last one quickly, and then I'll do it. S cubed equals 8. What's the answer? What's supposed to do? Yeah, for me, yes, sir. You had one to look good, but they said it. Yes, sir. Huh? Cube root 8. Very good. Cube 8. What you're saying, what times what times what give you 8? Well, we know 2 times 2 is 4. 2 4 is 8. Right? So this becomes, S becomes 2. So you're saying, what you have to cube to get 8? You have to cube 2 to get 8. Okay? So, cube, 5 cube is what? It's the last, maybe not less. 5 cube is what? 5 times 5 times 5. So 25 times 5 is what, guys? 125. So let's reverse it now. What is the cube root of 125? What are you asking? What times what? Sorry? What you have to multiply by itself to get 125. Then you will recognize it is 5. So the cube root of 125 is 5. Everything has a triangle. Show that 2a plus 5b, 2a plus 5b equals 171. Alright? What about this question is that you need to know that interior angles of a triangle adds up to 180. So these three must add up to 180. So what can you do? Let's start with this first one. A plus 2b, we add them, so plus a plus 9 plus 3b. Some persons could put brackets, but brackets will disappear over time, so they serve no purpose for the brackets. You rearrange them, you see what is, all of that equals 180 degrees. This is supposed to be 171 degrees. You can tell A with A, we have 2B, we have 3B, and then we have 9 by itself. So you can rearrange them A plus A plus 2B plus 3B plus 9 equals 180 degrees. From the get-go, you can see 9 from 180 will give you 171. You can see that easy. Okay? But let's go anyway. We have 2A plus 5B, which we had here already. 2A, 5B. We carry over the 9 and we subtract it. This is degrees, by the, I guess. This will be degrees. For now, we'll leave it as that, okay? So, 2A plus 5B equals 171. I don't think I have degrees, but it will be degrees anyway. Because that's where the 180, but 171 comes from the 180. Okay? So leave it like that. But, so we just show that. Except for the other one, for the quadrilateral, for the quadrilateral, show that 7A, show that 7A plus 8B equals 342. Again, the interior angles of this quadrilateral, this four-sided figure, will equal to 360. So we simply take down the angles, the interior angles, 18 plus 3B plus 6A plus 3A plus 2B plus 3B minus 2A, all of that must equal 360 degrees. Okay? Well, how much A's do we have? We have 6A. This will give you 9A. 9A, take away 2A, leaves you with 7A. So we already have 7A there. Then we have 3B. 3B plus 2B is 5B. 5B plus 3B is 8B. So we have the 8B already, as you can see there. Okay? Equals, then the 18 will go over to be 360. 360 minus 18. 360 minus 18. 5, 10, 8 from 10 is 2, 1 from 5 is 4, 342. Same 342. So 7A plus 8B equals 342. And lastly, they say, find out what is A and find out what is B. Whenever you see two things look like this, it's clearly dealing with simultaneous equations. So 2A plus 5B equals 171. 7A plus 8B equals 342. Okay? We're going to double. We're going to double equation 2, double 2 is dirty. We'll double equation 2 and we'll multiply equation 1 by 7. So the result will be 7 2s, 14, 7 5s, 35. 7 times 1 is 7, 7 times 7 is 49, down to 4. 7 1 is 7 plus 4 is what? 11 times? 1197. Good. We're going to double this 14A to 16b, 2 2s, 4, 2 4s, 8, 2 3s, 12. No, let's say 2 4s, 8, 2 3s, 6. Alright, so we're going to subtract equation, we call this equation 3, this is equation 4, this is equation 1, and this is equation 2. You're going to subtract equation 4. You subtract equation 4 from equation 3. 14 from 14 is now 8 from 8 is 0. 16 from 35. 16 from 15, that's what, 9. 19. So this will be 19b. And then we're going to subtract 684. 4 from 7 is 3. 8 from 9 is 1. 6 from 11 is what? 5. 513. Yes, correct. 513. And from my notes, 513 divided by 19 should give us 3. But let's backtrack. That's 3. 27. I'm saying, 27. Okay? So we're going to backtrack that quickly. 19 times 27. 9 7 63. 9 2 is 18. 18 and 6 is 24. 7 2 3 7 plus 4 is 11. 1 2 4 5 5 13. Yes, okay. So correct. B equals 27. So what do you do now? You substitute B equals 27 to any of the equations. Alright, then choose equation 1. Equation 1 will be the quickest. 2a plus 5b equals 171. 2a plus 5 times 27 equals 171. 5 times 7 is 25. Count 3, 10, 13 equals 171. 2a is 171 minus 135. Will that make sure going good? Yes. 171 minus 135. Because 7 is 6. 5 from 11 is 6. 3 from 6 is 3. So we get 1 from 1 is 0. 36 we have. So 2a equals 36. A equals 36 divided by 2. A equals 18. So we have A is 18 and B give me what? Oh, 20.